Let's take a look at some of the other protocols, technologies, and features we would use to secure, our communication. We've already talked about IPsec. Remember, that's the protocol that's built into IPv6, but was something we had to tack on to IPv4 because there was no inherent security. In IPsec, we use SAs, or security associations, which are simplex connections. Remember those? Those are the one-way communication only, and we use those to negotiate the ESP and the AH parameters. ESP, encapsulation security payload, AH, authentication header. If the two systems that uses IPsec uses ESP, one is security association each direction, so it needs 2. If it also uses AH parameters, it needs 4. And we use a unique 32-bit SPI, a security parameter index, as an identifier for each of the SA connections. ISACAMP, or Internet Security and Key Management Protocol, is used to manage the SA creation process. And we can use IPsec in either transport or tunnel mode. With tunnel mode, we encrypt and authenticate the entire packet, including the header. That's used on systems that does not natively speak IPsec. Whereas transport mode, if the system already speaks IPsec, we really only need to encrypt and authenticate the payload. And IPsec uses IKE, Internet Key Exchange. And the IKE protocol negotiates which kind of encryption and which types of hashes we want to use for that one connection. It really depends on what the systems can handle. It will normally choose the highest level of security and the fastest protocol that both sides can use. If one side has AES and DES, the other side only has DES, then it'll choose DES. If both sides have both protocols, it'll use AES because it's faster and much more secure. We use IPsec to protect the data flow between either a pair of hosts, host-host communication, between two networks, or a network and a host. It is an end-to-end security scheme that works on the internet layer of a TCP/IP model, or if you want to reference the OSI model, it will be layer 3, because, that's where IP addresses are. We use SSL, a TLS, to give us confidentiality and authentication for our web traffic. And they're both cryptographic protocols we use for our web browsing, email, internet faxing, instant messaging, voice over IP, and many other things. You download the server's digital certificate, which, remember, public key infrastructure, public and private keys. And we mostly use SSL for web traffic, and TLS, or transport layer security, we often use for internet chats, email client access, but some progressive websites do use it since it is more secure than SSL version 3. 15-20 years ago, ISDN connections were very common. ISDN is an abbreviation of Integrated Service Digital Network, and they work on layer 1 through 3 on the OSI model. The big difference between ISDN and a dial-up modem was these were actual digital transmissions over the copper. And they also use the PSTN network, Public Switched Telephone Network, PSTN. It would use circuit switching for either the voice or the data, and then packet switching for data. And you can buy them in increments of 64 kilobit. If you wanted a faster connection, you would bond them. DSL, or Digital Subscriber Line, is a family of technologies that transport data over phone lines. The by far most commonly used type is ADSL, asynchronous. With a normal connection there, you might get a 20 megabit download, but only a 1 megabit upload, hence asynchronous. Where if it had been a synchronous connection, you'd have 20 in both directions. And you can use DSL with a regular landline. Remember, that's where you need the filter to ensure that the data traffic doesn't interfere with the phone conversations. Back in the day when we did use dial-up modems, a security feature we could have added was callback. We would dial up to the server computer, identify ourselves normally with the username, and then drop the call. So we'll then go look at its lookup table, seeing Bob just called in. This is the phone number I have for Bob. I'm going to call Bob back. Once our modem gets the call, it answers and communication is established between our modem and the server. You could also add a caller ID, but caller IDs are really easily faked. The caller ID would just add that unless Bob calls from this number, don't call him back. So both legacy features, but it is something that I would know for the exam. In IT today, we use remote administration for, pretty much everything. Our networking team will log into routers, switches, all of our network equipment, do configurations, maintenance, whatever they do. The same with the server team, the storage team, the backup team. It is more and more rare that the engineer is actually in front of the piece of hardware they're working on. Why would they waste 10 or 15 minutes walking over to it or an hour or two driving there when they can just log in and do exactly the same work from their desk? And really, any computer, any device that has an internet connection and has the capability can be controlled from anywhere. As you may or may not know, I live in Hawaii. My parents live in Denmark. That's pretty much on the opposite side of the planet. So I have a program on my mom's computer. When she needs tech support, I can remote into that computer and fix her problems. I don't have to travel for 24 hours to help her. RDP, a remote desktop protocol, is a Microsoft proprietary protocol. Proprietary just means they own it, only they can use it. And on most Windows systems, it is installed by default. You may have to go in and configure something for it to work. And if you have a home edition of Windows, maybe you can't. RDP uses a web GUI or a graphical user interface. And as you may and may not remember from when we talked about the ports, it uses TCP and UDP port 3389, which is excellent if you have a Windows system. But obviously, a lot of what we have are not Windows operating systems. VNC, Virtual Network Computing. It's not Microsoft proprietary, and it can run on pretty much any OS using screen scraping. It was mostly used in the beginning for remote access of computers, remote administration, but it's also used a lot now for RDP sessions in multi-user environments. That's basically help desk say, hey, thank you for calling us. I hear you have a problem. Can I take over your computer for 2 minutes while I fix the problem? You then allow them access, and they can use your computer as if it was theirs. And hopefully they fix your problem. And there are hundreds and hundreds of different programs and protocols out there that we can use for remote administration. Many of the newer versions uses HTTPS. Remember, TCP port 443, and it's just a secure browser that has a web GUI you can use. You install the software on your system, you set a username and password, then the system you're connecting from, you do the same. Now you can control that system from wherever you are. Some of the very common ones could be Chrome Remote Desktop, Log Me In, Go To My PC, or Support.me. They all pretty much do the same, but some of them have a huge price tag and some of them do not. As with many other things, the more you pay, the better features you get. VDIs, or Virtual Desktop Infrastructure or Interfaces, depending on who you ask, is often something we refer to when we're talking about thin clients or zero clients. A thin client would have the normal hardware you would have in a computer, except their hard disk. It has the lower-level operating system, the BIOS. The BIOS performs the post, and then it downloads or points toward a kernel and the actual higher-level OS. A thin client application is a website that has the application that you need. You go to the website, then you access the application. This could be Google Forms, any application in your company that's housed somewhere else and not on your PC. Thin clients are most awfully stripped of non-essentials. It could be CD drives, most of the ports on them. They're not the big clunky workstations we used, they're normally the size of a small modem. Zero clients take this even a step further. They are even smaller, they have even more stuff removed. And because of this, they are cheaper. And they really have nothing stored on them. Just a way for you to access a server or client somewhere else that has everything you use. It is a little bit funny. 20-30 years ago, we moved away from mainframes onto autonomous systems because we wanted that flexibility. Now in many places, we're moving back to something that's not mainframes, but the structure is very similar. From a security perspective, it makes sense. We don't have a bunch of workstations scattered around our organization that, if stolen, could compromise us. Workstations log into a centralized server that's in the middle of our data center, where we should have a much better security posture. IMs, or instant messages, is another great productivity tool, and it can also be the opposite. If someone's on Facebook all day, they might not get a lot of work done. But for the intents and purposes of the system, I guess that doesn't really matter. IMs are short messages sent by either two parties or from one person to a group. Some of them can have real-time messaging, meaning as you type a character, it's transmitted, but most of them today need to do something before your message is sent, normally hit enter. And as they have evolved, a ton of features have been added. You can add files, hyperlinks, voice chat, video chat, or super awesome and funny GIFs. Some of the commonly used IM protocols today is RC, Jabber, or Link, and still used but very, very obscure by now is ICQ and AIM. Because, well, better technologies came along, and they didn't evolve. Today, though, most of our instant messaging is done embedded in some other platform. That could be Facebook, Twitter, Google+, WhatsApp. That platform has a suite of things they offer, whereas the instant messaging is just part of that. And most of them are horribly, horribly unsecure. They're built for functionality. They're not built with security in mind. In a report from 2014, 7 out of the 39 instant messenger services they looked at got a perfect score. Most popular instant messenger got 2 out of 7 possible. They don't need names, but I'm pretty sure that's Facebook. IM connections most often send stuff in plain text, easy to eavesdrop on, and it does at times require us to open UDP ports, which then can introduce other security vulnerabilities. And you obviously know, don't send anything sensitive over an instant message. That's just not the medium for doing something like that. Web conferencing is kind of an umbrella term for a lot of things. It can be webinars, webcasts, peer-level web meetings, or 50 other things. It could just be a meeting where everybody calls in. Since everybody is logged in, they can see the presenter screen. The most commonly ones used today would be WebEx, GoToMeetings, Google Hangout, TeamViewer, but just like so much other in IT, there are hundreds of different kinds. Some paid, some free. Again, the more you pay, the better features you might get. They use TCP/IP connections and often use real-time point-to-point communications, as well as multicast, one sender, many receivers. And we often use this, in a business setting at least, if we are geographically dispersed. And many of them have obviously the voice feature, the video feature, and then some sort of built-in chat feature as well. Often used to, hey, can you send me this bit of configuration? Then you paste it in the chat window and they get it. I've also used it for training. Students join, I share my screen, maybe have a camera so they can see me, and then I do lectures. Most of the time they would be muted because the rest of the class doesn't really need to hear them eating chips, coughing, sneezing, or doing something else. But if they have questions, they just type it in the chat window. But obviously, as IT security professionals, we need to make sure that what we're implementing aligns with our policies. Many web conferencing platforms use SSL or TLS tunnels, which means they punch a hole through most of our security. Everything's encrypted. How can we tell if sensitive data is leaving our organization? As with many other awesome productivity tools, we obviously need to ensure that we have security in place that we need. Easier very rarely means more secure. WAP, or Wireless Application Protocol, was widely used in the early 2000s to access data over mobile networks. A web browser is a microbrowser. It doesn't have the full functionality of a regular browser, but it also uses less resources. At the time, was really smart. But we don't use it anymore because, well, our phones and our connections can handle the full browser. The WAP browser would access sites written in WML, Wireless Markup Language. It's based on XML. But since it has been replaced by better and newer technologies, it isn't really used anywhere. Just know it for the exam. And then finally, CDNs, Content Distributed Networks. A lot of the large content providers, I don't mean internet service providers here, I mean sites like Amazon, Netflix, Google, to a large extent use CDNs. If you look at the graphic over here on the right, top picture is a normal infrastructure. We have 5 computers all over the world needing to access a server. They go to that one server. Depending on how far away that server is, now they get great or horrible response times. If we use a CDN network, the picture on the bottom, we have a server, exactly the same content as all the other servers, close to each client, meaning everything loads faster. And if in the example at the bottom we assume that's Google, I type in google.com, the DNS entry sends me to the Google server with the lowest latency. One I'm going to get a response from fastest. It does for the providers also give some DDoS protection. In the case of Google, obviously they don't have 5 servers. They might have 500 or 5,000. If someone launches a DDoS attack on 5 or 10 or 20 of those, it doesn't really matter because the other 4,980 servers are still up. And latency or delay is really one of the big selling items you can provide your customers on the internet. My website loads half a second faster, I'll use the same search engine again. If my video doesn't stop all the time and buffer, I am a happy customer. I will keep using your service. So having that decentralized infrastructure really makes a lot of sense if you provide some sort of service to your customers. Most websites, it doesn't make a lot of sense because the cost would just be tremendous.